1D here. I have it's the fourth one we've done. It's actually really similar to part B of number 1 on the study guide. If you look here, there's a subtle difference in how this notation is set up. It says 4 plus, so what that means is 4 from the right side. In this case, it turns out to not really matter, and I'll worry more about that as we move along through some of the other ones, like, for instance, F. Anyway, if I plug in if I plug in 4 to the bottom, I get 4 squared, which is 16, minus 5 times 4, which is 20, plus 4, which these guys make a positive 20, cancel with the negative 20, give me a 0 in the bottom. Hence, I need to use limit techniques to deal with this. So the first thing that I'm going to do is factor the top and the bottom. So I'm going to write equals limit as x approaches 4 from the right of, that's difference of 2 squares in the top. So it's x plus 4, x minus 4 over, the bottom is going to give me x. I know that since I plugged in 4 to this thing and got 0, I know that this is actually going to be one of my terms in the bottom. And the reason I know that is because if I have x minus 4 times something, remember, I plugged in 4, I got 0. Same thing here. I plug in 4, for x right there, I'm going to get 0, which is going to multiply out with this thing and give me a 0 in the bottom. Now I just got to figure out what goes there. Should be easy. It is x minus 1. So notice now I've got an x minus 4 in the top and the bottom. So they divide out, cancel. So this gives me equal to the limit as x approaches 4 from the right of x plus 4 over x minus 1, like that. Which now I can just plug in 4, and that gives me 8 over 3. That's my answer. Good with that, that's fine, but I'm going to show you a little bit more of why the answer is 8 over 3 from a graphic perspective. So if you were asked back in Algebra 2 to graph this thing, you would factor it, you would cancel it, you would have this thing. So now we go and we graph this thing. It's got a vertical at x equal to 1. It's got a horizontal of y equal to 1. The x equal to 1, remember, comes from the denominator. The horizontal comes from this coefficient divided by this coefficient when the power of these two x's are the same. So if I had x squared and squared with a 1 and a 1 out front, then I would get the same thing. If I had x squared with a 7 and a 3, then this would be 7/3. Anyway, so I also know that this thing passes through. It has a 0 of negative 4, and that's because that's what will make the top of the fraction 0. So negative 4 like this, which tells me that it goes like this. It's one of these rational functions that looks like a variation of 1 over x, like that. So this thing, I guess I should have done it in a different color than what's up there. So anyway, that thing looks like that. With the exception of, so this was 1, 2, 3, 4. So at x equal to 4, this thing is undefined, which means that, what I mean by that is that I cannot plug x equal to 4 into this because I get something over 0. And that comes from this piece that got canceled on the top and the bottom. So I just graph this thing, which is exactly the same as this thing, everywhere except at x equal to 4. So instead of having a solid line, well, a solid curve that goes like this, what I have instead is, oops, wait, what am I looking for? Erase. I have a little hole right there. What I mean by that is that this thing goes here, it gets a hole, at x equal to 4. And since, and what I'm looking for is the limit. I want to know what is that hole basically around? What y value is that hole around? So at x equal to 4, it approaches the same thing that this thing would go to. So this height right here, if it was actually lined up correctly with this thing, which it's not, would be my value of 8/3. So when I look at that limit, I'm just getting the y value of the hole. That's all I'm doing. And that's true for any of these where we cancel the same term out of the top and the bottom, which actually often happens in most of these.